So I've got an example that uses proof by induction to show that the series 1 plus 2 plus dot 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 up to n can actually be re-expressed as just this simple expression, n times n plus 1 over 2. To start, let's look at the first case. And in the first case, I'm going to use a different letter than n because of anonymity. But I'm going to say that k equals 1. You got to start somewhere, and that's the trivial case. Well, then what that means is 1 equals 1 times 1 plus 1. I guess this is a question mark. We're going to check on that. Over 2. Simplifying this, we get 1 times 2 over 2, which of course reduces to 1, and that check mark does confirm. Now we check the second case. And for the second case, the structure still has the same feel. Let k be a number bigger than 1. We already checked 1. Check number's bigger. And we also have to assume that the thing we're trying to prove is true as long as we assume it's true up to a point. So let's assume that 1 plus 2 plus dot 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 up to k minus 1 is equal to k minus 1 times k minus 1 plus 1. Now, this k minus 1 is in the exact same position as that n, and all of this is just like n times n plus 1. Lots of weird symbols. Let's clean it up. So cleaning it up, we get k minus 1 times k, because the negative 1 and the plus 1 cancel, divide by 2. It looks a little different than this, and that's okay. At this point, we need to consider what would happen if we did the summation 1 plus 2 plus 3 plus dot 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 all the way up to k minus 1 and then up to k. But because of this fact right here that k minus 1 times k over 2 is equal to that summation, we're able to just swap it out. The k is still there because that's our induction step. We're pushing towards k. And then if we simplify this, maybe something interesting will happen. So first of all, I know that I need a common denominator. So over here, I'm going to multiply both sides by 2, and in that numerator, denominator multiply by 2. We would have k minus 1 times k plus 2k, and all of that over 2. Now this k right here and this k are common factors, so if we factor that out of each of these products, we'd be left with k times k minus 1 plus 2 over 2. Here, the minus 1 and the plus 2 simplify to being plus 1, and I know I'm smushed into this part of the board, but we get k times k plus 1 over 2, which, change the letter, is exactly what we started with in our original assumption.